right, welcome back to Lag Demon Programming. This is the compiler design course. I'm Bill Westlake, and we are working on our type system. We've added lists, or excuse me, we've added lists and tuples. We've also added records and enumerations of a very special kind. But then I realized that we need to do some refactoring, and that refactoring was a little bit tedious, and I'll explain why we had to do the refactoring. The type system that we employed initially was a very simple type system that was based on this enumeration that we have up here at the top. If I can crawl up there, these types. Okay. Well, that's fine, but we have now introduced some complex types which are impossible to represent with just these enumerations. So we need to employ a class to represent all of our types so that they're all of the same type. So that in the context of the AST, we can have a type be more than just an enumeration. It can describe more information about that type. The enumeration works fine with simple types. It does not work so well when we have structured types and we need to have them become a type. We can say that it's an enum, but we can't say what that enum entails, so we have to have an object. As such, I have done the refactoring, and what I'm going to do is just pull it over and all of it over and show it to you and explain to you how I refactor it. But it was very tedious. A lot of little bits and pieces need to be changed, and I don't see the need to do that on screen. But I can explain the refactoring very simply. So I'm going to do is pause the video and pull that all in, and then I will go through and explain it. So I will be right back. Okay, I'm back, and I've copied over the refactored code from my prep area where I test things out before I show them to you. And this is what I've done. So we still have our types up here, but I've added some in. I've added list and tuple, and we've got our record and enum types. Good. And then I've added a type class here that's based off function node that holds a type, and you can get the type, and it's got a visitor accept on it. And then I've also created two other types, a tuple type. This is a type spec of a tuple, not to be confused with the tuple class, which holds an actual tuple. This holds the specification of a tuple, which is its list of types. And so that's what we have here. Oh yeah, I also created this type def for a type list. So we have a pointer to a type list of types. And then this fills in, and the type of this is tuple, but it contains a list of other types, which are the types within the tuple. And of course, we have an accept on it. And then we have a list type, which is really simple. It only contains that it's a list type, but there is one little thing that I have to fix here for the list type, which is it needs its own type. So it's type of list, but I forgot to do this, which is protected, and we're going to say this is types, and we're going to call it list type, and we'll just pass in here types underscore list type. Oh, actually, no, it used to be a type pointer, list type. And the reason is because you can have a list of lists or a list of tuples or anything else. This needs to be a type pointer, list type. And then we need to come here and go underscore list type, list type. There we go. And then we need to be able to get the list type. So we need to go type pointer, get list type, not to be confused with the get type, which would tell you it's a list. And we want to return underscore list type, which is the types of the elements within the list. But there's only one type for a whole list, so it's got to be the same element. Okay. We do a make sure everything works. And it does. Okay. So now what we need to do is be able to specify the type. So we've got our numeration and record, and we've got lists, and we've got tuples, like this one. This is a tuple, but we need to be able to specify a list type, and we're going to do the list first. We'll make it really simple, and we'll just put one here. We'll call it Q, and it'll be of type integer list. And just by putting the keyword list after a type is what will tell it's a list. However, tuples are a little more tricky because we would have to tell it all the types the tuple contains. And so that's really simple. We will go int star string star and a my type here with a semicolon. And that's how we would create a tuple type, telling it it's going to be a tuple of 3 values. The first one's an int, the second one's a string, and the third one is some type of my type. That's what we have to be able to parse. So let's do the list one first. So we need a keyword in here. Let me make sure I didn't already create it because I had that stumbling block before. No, I did not. So we're going to call this list, and we're going to return list. And we'll go over here to our parser, add that key, add that token in. We'll put it right here. Let's go to another line. Percent token list. Okay, so we have list. So let's find our list definition down here. We have our tuple. Here's our list. So just above this list here, I'm going to put list decal. This is a list declaration, and it's going to be a type followed by the keyword list. Will be a list declaration. And so what is a list declaration? A list declaration needs to be of type list pointer, so we need a list type pointer, and we'll call this a list decal. And so we'll come down here and we'll go percent type list decal list decal. Now we should be able to fill this in. Where did I put it? Here's our list decal. So we should be able to go here and just say that $$ equals new list type and pass in the type, which is $1. So a list decal is one of the possible types, and we notice that the list decal is of type list type, which is a base class of list, and that's what our base class of type, which is what type is now. Let me show you up here. Part of the refactoring was changing this all around so that type is now a type pointer, and our list decal fits into the types just fine. So if we come down here to our types, here's our types. One of them can be a list decal, in which case it's just $$ equals $1. And so this should build. And it seems to. And we got a segmentation fault, probably because I haven't defined. We got to go back to our test.fng. I need to take this tuple one out. It doesn't understand that yet. We'll try it again. And there it is. And you notice Q is of type list now. But when it's, we really need to put, when it's a type list, we need to put out more than just list. And that's where our, that's where we're going to fix up our pretty print. But we'll do that later. For right now, we know that Q is definitely a list. We'll put the type in there when we get to it, but it did parse it. Good thing. Now, the next one we don't need a keyword for because we're just going to use a pattern. So let's find our tuple. So here's our tuple, and what we'll do is we'll create a tuple declaration. So let's go up here. We've got our list type. Let's get our tuple type pointer. We'll call it a tuple decal. Good. And then here we'll go percent type tuple decal, and we'll do it tuple decal. If I didn't explain this carefully, the reason we can use the same names, which also makes this a little easier to read, is these are two entirely different scopes. This tuple decal is an actual C++ field in a union called tuple decal, whereas this is a pattern within the actual parser. So they can be the same names because they're not associated with each other in any way. They're not even these names do not become code names. These are states within a state machine. So if we find tuple, we can come here and do a tuple decal. Needs to be this special form where we have a list that's separated by asterisks, a list of types that are separated by asterisks. So what we need then is a tuple decal list. And a tuple decal list, to be a tuple, well, you can't really, it makes no sense to have a one element tuple because that's just whatever the type was. So it's got to have at least two. So what we're going to say is it can be a type followed by a, asterisk can have more than one scope or more than one use. And I believe that we have it here as times. And that's probably a bad name for it because it could be used, star could be used for more than one thing. This asterisk could be more than, but for now we'll leave it times because I don't want to go change it wherever we've used it. So what we'll do here is we'll say times type, or it can be a tuple decal list followed by times followed by a type. Okay, and actually we can just make this a tuple decal and a tuple decal, and we don't need, that's all we need. We don't need to make a separate list because that's all it is. It's a type, star type, or it's that followed by a star followed by another type. So it's at least two to be a tuple. And so then again we find our type and we can go that it could be a tuple decal, in which case it'll be $$ equals $1. And then we can, let's build that, make sure it works, we get everything right. Looks like we did. We do have some, they're not really errors. warning type default action record, where's error. It doesn't like, oh, I put that in there, and I think I got another one here. Yeah, we don't need these. We're covering the error up top. Type times type. Why doesn't it like that? Warning, type clash on default. Tuple decal does not equal type. Oh, because I left the default action. We've got to fix that. So tuple list decal, I didn't fill it in. Tuple decal, I forgot to fill this in. So what we will do is we will go $$ equals new tuple type, but we have to add in the list. So actually we need just a little bit more space here. Tuple type has to have the list. So if we're here, we're making a new one. So we will just do, we've got to have, I actually do need to have this does need to be of type list. Tuple decal list. And a tuple decal list, we're going to come up here. We've already got a list type, list decal, list pointer. How did I handle the list type? Oh, because it's only one. Do I have a type list? Enum pointer record type list. I created a type list specifically for the tuple, so we need to add type list up here. Type list pointer type list is different, and so we need to have percent type list tuple decal list. Okay, so these don't need semicolons after them. Okay, so the tuple decal list is a list. So $ equals new type list, and then $ pointer pushback $1, and then $ pointer pushback $3. And we can pull this up here. Well, maybe we'll do it like this, and we'll put these down. This is a little easier to read. Do this, and then here it's just going to be $ equals $1, and then $ pointer pushback $3 again. And so then we can do a make. No, we can't. Type decal. Oh yeah. So now we need a tuple decal is going to be a tuple decal list, and what we will do is we will go $ equals new new tuple type $1, and that'll put the list in there. Oh yeah, and we need a semicolon after that. There we go. type. Tuple type. What? Type decal. Tuple type. What am I missing? Not that. This type. Tuple type. This type. Okay. Tuple decal. This is type tuple decal. Is a tuple decal list. So $, new tuple type $1, which takes a here's our tuple type. It takes a type list pointer. $1 is a type list, tuple decal list. $, equals $1, pushback $3. Why doesn't it like that? Tuple decal is used, but is not defined. Type decal. Tuple decal. And now we've got pushback $3. Cannot tuple type pointer to type list pointer. Tuple type. $1, $3 is a type, which is a type pointer. This is a tuple decal. Do I not have tuple decal defined right? Let's go up here. So here's a tuple type, tuple decal. Okay, and then we have tuple decal, type list, tuple decal list. That's a tuple. Okay. And type list, tuple type, tuple decal, type list, tuple decal, tuple decal. Oh, tuple decal list is a type list. Tuple type pointer to type list. What? Tuple decal list. Oh, this should have been tuple decal list. And there it is. And let's see if it bombs. It did not bomb. Let's go add our tuple in here. We'll call it R, and it's going to be an int star float star string star my type. And we'll try it. And we got my enum. Did we get an error because it didn't print the record at all? Unexpected type ident. Okay, well, we got to probably fix that. Let's take that out of there for the moment and see if it works this way. Int star float star string. Okay. We have to beef this up a little bit, so what I'm going to do is I'm going to go ahead and create a keyword. I forgot. I did run into this problem before. And so we're going to do it this way. We're going to, oh, darn it. We're going to go up here and add this token in. List. Tuple. And we're going to change the way we define tuple. Tuple, parent tuple. Here it is. And what we're going to do is go tuple followed by a tuple declaration list. And then we'll come over here to our test FNG and we'll say tuple. What doesn't it like? What do you mean type list is used but isn't defined? Oh, this should have been. Darn it. Should have been type list here and tuple decal list here. We already have it. Make. What doesn't it like? $1 of tuple decal has no declared type. Oh, because this now has to be $2. Make. And it still isn't liking it. Tuple decal list. Oh, probably because I didn't add tuple. Did I not add? Oh, we've got tuple here as an expression type. Oh, that's the expression type. Up here, record. Where did I add in list? Literals, no, that's right, types. Type, we've got a tuple decal as a type. And a tuple decal, did I say tuple? Tuple, int, float, string. Tuple, tuple decal list. Tuple followed by tuple decal list. Double check my Lexer. Should be returning tuple. Let's look and see if we got an error. Unexpected C brace. Oh, I forgot to put a semicolon at the end of it. All right. And there it is, and it came up a tuple. So now we can fix the pretty print for when we get tuples and lists. Pretty print. So where did I put them? I know they're here. Well, let's go up to the top. And visitor type, tuple type. So we don't want to just print out the node.type. What we want to do is go tuple and then actually we want to go grab this. No, we just want to get rid of this. Okay. We'll put out the word tuple, then we'll go for auto n colon node pointer get types. dereference that, and then we need to go standard cout from, first we need to go int len equals node pointer get types pointer size, and then int I equals 0, I plus plus, cout from types to string n pointer get type if I is less than len, standard cout from quote space star. A space. Semicolon. Okay, let's see if that did what we expect. What didn't I like? Get type. String to get type. Oh, here we go. Just a missing semicolon, and here we have our tuple. Okay, so we're not visiting it when we do when we come upon a type anywhere. Yeah, this is going to take a little more refactoring because we have to visit. We have to do this. Instead of doing this, that's when it's a parameter. Yeah, I don't want to list all the types when it's a parameter. I only want to list the types when it's a record or an enumeration. So here's the record. What we can do here is end this. Get type. We don't do that. What we want to do is go node n pointer and pointer get ident get type get field list. Oh, so this is a field. Okay, I'm going to come back to this after I figure it out. Instead of trying to figure it out in front of you, I'll figure out how to pretty print this stuff and then we'll do it. For now, it's showing that it's compiling a... let me build this real quick, make sure it still builds. So it is showing right here, list and tuple. It is compiling them, it is finding them, and it's printing the type there. We want it to specify more about that. We'll get to that in the next video. Right now we're at 34 minutes, it looks like, 31 minutes. So thanks for watching. I hope you liked it. If you liked it, hit that like button. If you really liked it, hit that subscribe button, and I will see you in the next video. Thanks for watching.